Hi and welcome. In this tutorial, we will create a scroll animation that mimics a video playback effect on a web page. As we scroll down, the frames of a pre-extracted video sequence will update seamlessly on a canvas element, giving the illusion of a blooming flower unfolding effect. We will use React, GSAP with ScrollTrigger, HTML canvas element, and Lenis for smooth scrolling. We will start by preparing our assets. First, we will find our video. Then we will extract frames from a video and optimize them for the web usage. Then we will dive into the code, explaining the foundational concepts, logic behind each major section, and a line-by-line code breakdown. By the end, we will have a fully functional component that you can integrate in your projects. Let's start by selecting an engaging video for extracting frames from it. At pexels.com, I find the flower blooming video, which I find good choice. I'm using the part of the video where the flower actually blooms. It's from 4 to 8 seconds. This part of video gives us a really nice sequence to animate. To make the animation smooth, we're going to grab about 60 frames in total, with a 80 milliseconds difference between each frame. 60 frames with 80 milliseconds difference between frames is around 4 seconds of the video. That's exactly what we need. After downloading the frames, we can notice they are pretty large in size, almost 80 megabytes. That's way big for the web. To optimize them, we will use Squash Image Compressor. We will change its format from PNG to WebP. We reduce its size from 78 MB to just 2.5 MB. In real-world app, I suggest to check the WebP format compatibility on Caniuse.com and provide fallback image if needed. You can read my blog about media optimization where I showcase the fallback image usage. Now we can start code part. The core idea is that we preload our images asynchronously, monitor scroll progress, and draw the frame we need in real time on canvas element to get the video-alike animation on the scroll. Here we have our base Next.js template. First we will create our hero component and import it on home page. Also make sure you're using useClient directive because we're gonna use React hooks in our app. Let's import our assets in public images frame folder. That's all assets we need. Also, we need to install our dependencies for this project. It's GSAP and Lenis for smooth scrolling. We declare a frame count for our animation and created getCurrentFrame function to generate each frame's file path. Next, we will use React refs to interact with the canvas, store loaded images, reference our content block for later animation, and keep track of the frame we are displaying. The setCanvasSize function will ensure our animation looks sharp on any device. Here we set and regularly update the canvas size based on the window and device pixel ratio. Here I will pass the JSX code. Nothing special here, just make sure to attach refs to canvas and content element. And also make sure you're using Transform 3D and Perspective Distant Tailwind styles. These styles will allow the children element animate in 3D. The render function draws the current frame to the canvas element, centers it, and scales it for the best visual fit. Here I find mistake I made. We have images ref, which should be an array of image elements. Now it works fine. In our main useEffect hook, we register ScrollTrigger from GSAP. set up the initial size of canvas element, preload images using promises. Also, I added scroll into view method to body element to make sure that we always start our view from top of the page. Here we're using promise all to wait for all frames to be downloaded in parallel. Also, we can see that we're resolving our promises both on load and on error states. It means that even we could not download some frames, the function will continue its execution. Once all images are loaded, we render the first frame and attach our scroll-triggered animation to it. We are preloading our images using promise for each frame. Once each promise resolves, we save the all images in our images ref, render the first frame and initialize our scroll animation. The benefits of this approach is all images load in parallel, speeding things up. When using preloading, usually we want to use loading component to show to the user while we're preloading. Here's the exact place where we can hide our loading. Once all frames were downloaded, we can hide our loading component. Time to create our ScrollTrigger function. Here we're creating our ScrollTrigger on the element with the hero class name. It starts when the top of the hero reaches to the top of the browser window, that is, immediately. It ends after scrolling a distance equal to 5 times more than the window's height. If we want to make our animation smoother or faster, we want to change the value of 5 to get the animation effect we need. I suggest to try values between 2 and 8. Pin value keeps the hero section fixed in place while scrolling between the defined start and end points. Pin spacing keeps layout unchanged, so content doesn't shift. Up makes sure the animation moves in time with our scroll, but not instantaneous. Instead, it takes about a second to catch up with our scroll position, making the movement smoother. Next, we have onUpdate function. This function runs every time the scroll position changes. Progress is a number from 0 to 1, represents how far we are through scroll area. 0 means we are at the very start of the scrollable section, 0.5 means we are halfway, and 1 means we reached the very end of the scroll range. Here we take progress and divide it by 0.9. This means we want the animation to finish earlier, at 90% of the scroll distance. In short, it means our animation will end at 90% of the scroll weight. Target frame calculates which image frame should we display. After calculating, we just change video frame ref and re-render our canvas with new calculated image frame. Next, we have code from zoom effect animation. This animation moves backward using a 3D effect. This effect happens based on how far we are scrolling. Here we are checking if the scroll progress is less than or equal to 80% of the scrollable area. It means the animation is active only for the first 80% of the scroll distance. After 80%, the text is hidden with opacity equal to 0. Z-progress divides the scroll progress by 0.1 to get a number that grows faster. This helps control the zoom effect. For example, at the start this value is equal to 0, but in the middle of scroll it's equal to 4. Then we multiply it with -600 to calculate the backward value for translate Z style. This style controls 3D zoom effect. Next, we have if statement. Here we are checking if we are scrolled at least 20% of the way. We don't want the text to start fading right away, waiting until 20% progress happens. This will let users read the text first before it starts disappearing. Fade progress calculates how much the text should fade. Next, we are applying our styles to content ref element. You might notice that we are duplicating the translated styles, which is already applied via Tailwind CSS. This is because CSS allows only one transform property per element. To combine multiple transformations, such as translate for centering and translate Z for the 3D effect, we must define them in a single transform declaration. If we don't, the translate property just won't apply. If we've scrolled for more than 80%, we just set the text opacity to 0. Handle resize function will be called whenever the browser window is resized. This function will keep our canvas element responsive. ScrollTrigger's refresh method is recalculate all ScrollTrigger instant values. We also implement cleanup logic to remove event listeners and ScrollTrigger instances from the DOM when the component unmounts. To make our animation smoother, we're gonna install Lenis. Here in the main page, we will add Lenis smooth scrolling for entire page. This is pretty easy. We'll just import Lenis React component and wrap it our entire page. As we can notice, our page is more smoother than before. Our component is ready to use. The full source code available on my GitHub. Check the link in the description. If you like this video, please like and subscribe for more content. Thank you and see you in the next one.